So sorry for not being there on site. It's my first PyCon that when I will be presenting online because of the COVID. I found out just before the conference, so I couldn't make it. And today we will talk about event-driven architecture and how to make it very easy with AWS support. We will obviously start with the usual agenda, so a little bit about me. I'll try to keep it as short as possible. Then I will go through a few terminology that can be a little bit confusing in some cases. Then we'll cover the event-driven architecture. We will compare that obviously with microservices, the standard approach. We will talk a little bit about what are the good event practices. Then we'll move to the AWS solution that's directly created specifically for handling event-driven architecture. We will discuss the library we are using in our projects, show some code examples, and then there will be time for questions and answers. About me, so I started working a long time ago as a photojournalist. I even had my episode as a war photojournalist, and then switched careers in 2014 to Python developer, then moved up in ranks, and now for the last 2 years I'm working as a CTO. Currently at LocalBini, and before that at NordCloud in Poznań. There was even a period there when I worked as a CTO in two companies for 2 months, but it was not manageable. In my spare time, I do a lot of climbing and hiking. I play board games. I do some woodworking. As you can see in my background, there's a Japanese wall that was fully made by myself. And I'm still into photography because that's where I started, and I love to do those photos. And on the right side of the screen, you can see my lovely daughter Kira in the water. So that's my last time consumer, and that's using all of my personal time. And I will shortly brief what we are doing at LocalBini. So LocalBini is a tech startup focused on traveling. Basically, you can think about it as Uber for travelers. So the objective here is you go to a city and look for interesting experience in your area of interest. So if you are, for example, illustrator or drawer or painter, you would like to meet some other painters in, for example, London, Berlin, or wherever you go for your trip, and have ability to show them the best places to paint instead of just the normal places for average tourists. We have a lot of very interesting experiences. One of the most sought for is the branch with astronaut. Basically, you cannot meet an astronaut on the street, so you need to have that approach here and be able to talk with him. It's a really nice opportunity. And I'm also hoping to visit him next year. This year was a little bit restricted still because of COVID in the past. And there are also simpler experiences, we call them experiences, like 10 things that you can make to Berliner, or 10 things that you can do Poznań, Warsaw, or Gliwicz. I'm not sure how to pronounce that fully correctly. That are still delivered by a local person that is living and breathing in the city they are for last years or most of their life, and they can tell you a little bit more interesting facts. For example, when I was checking out the tour in our office in St. Gallen in Switzerland, I get to know that St. Gallen, a small city, 90,000 people, is the 10th city in Europe when it comes to consuming cocaine. You will not find that easily, that information, but it's confirmed, and I've even checked that, and that's true. So it's really interesting to meet and visit cities in that way. So that's why I'm here also. Moving forward, terminology. So there are a few things that I will be mentioning often. The AWS, most of you probably know Amazon Web Services, the cloud service provider, currently the biggest one, but it's not that important. Every other thing can be done in other service providers like Azure or GCP, the Google Cloud Platform. Azure was for Microsoft. Lambda. We are used to that in Python. Lambda is the anonymous function that we can use for filtering, mapping, and a few other things that we are interested in. Here, every time I will be talking about Lambda, I will be talking specifically about AWS Lambda function, which is function as a service. that AWS is providing. Basically, you can deploy any Python code and it will be run when invoked in one of many ways. We will discuss today the ways of the direct our Lambda API. We'll discuss the event invocation, and we'll discuss a little bit the rest invocation. So we also have the comparison with that. Moving forward, direct API or Lambda API. I'm using those two terms in parallel. Basically, it means that basically calling directly that Lambda function that we defined in the first step that is processing our event request or direct request. Our REST request and direct request will be separated in many cases. Um, and it's very often used when you are developing on AWS because you can skip the REST layer of the API between those. You can directly call the Lambda as it will be in almost your repository. Obviously, there is some time that needs to be processed, but it's much lower than it would when we would go over through REST API with AWS. And last, most important term of all of this is the event. What we are thinking about the events. Everyone has some idea what is an event. Most of those ideas are correct. But what we will be thinking here is the meaningful and intended change of the data state. For example, user registered, changed his password, enabled MFA, booked something, bought something, removed his account. Whatever the user changed, whatever the user does, basically is meaningful change of data usually. Or current state of data. We will not focus that much on that, but there's a second good definition of event and event-driven architecture. Basically, that's a state of data that you are sending periodically, depending on what do you need. So if you have a, for example, Windows sensor, running for security, monitoring the processes that are being run there, taking the utilization and sending every 10 or 5 minutes or 1 minute information what's happening on the system. And that's also an event that is happening and is being triggered by time passed instead of meaningful action actually. Moving forward, event-driven architecture, also known very popularly as message-driven architecture. Those terms can be used in parallel. It's focusing on four things: production, detection, consumption, reaction of events. Production is basically the creating the event in our system by any means. The producers can be, as I mentioned, there can be some sort of sensors. You can also have like your water plant has a hydration sensor. You can also have that being sent every 1 minute to your server. That will be considered also an event. But basically anything that user does, and we want to see that. So we want to see the change of the password, but we don't really actually care that much about that the user is browsing our inventory on our site. Let's say we have a book commerce and we are selling books, so we don't necessarily focus that much on events that someone is actually browsing things. But when he buys something, that's the start of the process of business process interesting for us. Obviously, there's a whole branch of analyzing the things that the user did before, that is his mouse movements, etc. That is created in order to improve the way we are selling things, and you can see that on all bigger e-commerce platforms. That there's a lot of data being sent to their backends or providers like Google Ads about the user behavior and Google Analytics. So that's a little bit different topic. We'll focus on those that are relevant to usual business events. Moving forward about the event-driven architecture, we have the detection. Detection usually is measuring taking number of events, either a number of a time period of events, and analyzing those events in a larger perspective. And that's focused on a lot of things, and banking and finances usually to find transactions that are possibly illegal and mark them for analysts to actually check them. And security, we are sending a lot of events about what's happening, and if there's a simultaneous, for example, spike of specific process being run, it may mean that we are under attack, or there was a scan or few scans that were not supposed to happen. We want to trigger an anomaly event. And there are obviously many more ways of uh, examples of where we can detect events, but usually it's on period of time or number of events there. Then we have the consumption, which is very specific thing because consumption is very similar to reaction. The difference is basically that consumption is final, so when event is being consumed, nobody else can play with it anymore. Whatever the playfulness would mean here, it's eaten and it's done. With reaction, many things can react to the same event, and that's basically the most powerful thing about the event-driven architecture, the reactors that are taking the events, making actions, and moving along basically. And so many things can react to one thing, and I will explain that a little bit more on the next slide. Um, Benefits of the event-driven architecture is loosely coupled software, which is actually really good because the process of developing software becomes easier. And when we will compare that to the rest microservices that are directed, not reacted, you will see very clearly the difference. And the biggest benefit is obviously about everything that would be done asynchronously or can be done asynchronously. So when you are thinking about event-driven architecture, you cannot get rid completely about microservices and connections between. That's just the thing. Well, you can try, but it's almost impossible. But most of the things can be done asynchronously, and that's the biggest benefit there that you can see or have. So we have two examples, simple book, e-commerce bookstore. Same action, client buys a book. We have the order API, which then needs to connect to notification API that will send email with confirmation of the order, and possibly will send notification to our staff that they need to prepare that order or create a Jira ticket, whatever we have the process in business. Then it needs to call the invoice API that will create the invoice, and then the invoice API needs to call the notification API to send that invoice. Then we have the warehouse API, which needs to update the stock. And then we have the forecast API, which warehouse informs the forecast API if we need to possibly order more of that stuff that was bought, in that case, a book of specific author. And then we may have a promo code if was used to invalidate that promo code for the future. This is not a very simple example. It's a little more complicated, but that's how usually currently e-commerce services works in most cases. On the other side, we have event-driven approach, where the whole cycle for the customer finishes on the first API, creating the order, and then new order event is being created by that API, which can be consumed by all of our services. So those services will take that new order, and seeing the information in the new order, they will send the emails to respective members. The invoice API will send the invoice either directly or through also a new event. I will show that on the next slide. No, I will not. Then we have the warehouse API, which can actually send information that stock was updated. So it lowered, we sold one book. And then the forecast API can react to that and creating an order for that specific stock that was removed from the warehouse. And then promo code can be also consumed here if there was used. So you need to, well, basically all of the information about the order needs to be included in that new order payload in order for every API to consume. That's one of the approaches. There are more. I will also tell a little bit more. There are a lot of information that we need to cover at the same time. So if you are looking already about how I'm talking about the biggest difference, this is directed. So it means that the first API needs to know the whole process or most of the process about what's happening, and all of the APIs needs to be directly integrated with the first API in order that the whole service is working. For reacted, they don't really care that much if they are anything there. from one single API perspective. But obviously, from business perspective, those two processes are completely equal. The first one is just done on mostly in one API. The second one is completely decoupled in that specific case. And just to show an example, this is very opposite to in society. So society, when something happens, you have the event that someone got injured. When you direct other person to call, they will usually call and react to that order direction. In case there was event, someone fell on the ground, no, not anyone will actually act in most many cases, and I've seen that in the past. That nobody was reacting to the person laying on the ground. And with event-driven architecture, it would be completely opposite. Every of this person would check if I need to react. Obviously, nobody has to react. That's the point here, but they should check if they need to react to the event. So to sum up, the most important fact here is that producers are not aware, care, or interested about the consumers in event-driven architecture. Their job is to produce the event and forget about it. And if someone needs to tackle it along, they should do them on their own awareness. Moving forward with even good practices, basically the keep it simple model or keep it simple stupid model, if someone likes the next S, makes the full sense here, obviously. So we have event payload and we have in all events the event type. Both are very important. Both need to be in the event basically as a part of the event. So for the event types, well, it's also more important. Maybe it's obvious, but we should keep the same name convention always. So all event types are either uppercase or lowercase, snake case, whatever we prefer. But it should always keep the same name convention. Then we have the type should be showing what's actually being sent, what should be expected. And then, as I mentioned, we have two type of definitional events. So first one will be new user registered or new user or user password change or MFA setup or new order or anything that is triggered by usually a person, but it also can be triggered by another system. And then we have the, for example, health check that is sending information about the CPU, RAM, and hard drive, or the list of the processes that are being run in the background. Examples are everywhere basically, or the moisture of your plant in your home, or the air quality that you have in your home from your one of the devices. Then the second part, as I mentioned, is the payload, and there are three ways to go around it. The first is just setting the event type, so user registered and user ID of that user. And that would be sufficient because it lowers the size of the event. But with AWS EventBridg, we actually don't have to care that much about the size, which I will explain a slide later. So I will focus on discussing those two, the whole entity. So when the new user registers, all of the information of the user entity that were created alongside should be added to this event. Obviously, then you need to think about what actually shouldn't be added. For example, we don't want to send password or hashed password of that user to our system because no other system will care about it. So there are some information that should be cut out from it, but that will be very depending on the situation and the event type that we are sending. But usually whole entity should be attached to the event, or if you want to keep it very lean, still the only entity ID. But most cases that's better practice and our experience. And then the second alternative, well, the alternative to the first of two approaches is updated version of entity and original one, if there's a need of that. If you think there is in your specific case you want to compare some things and able to show the difference, it really makes sense to send both of the versions. But then you need to obviously prepare that in advance, and also your consumers need to be aware of that. a specific case of events. In our experience, in my experience, 99% cases are whole entities. We have 1% of cases where we actually really care about the change that happened. But it's, as I mentioned, very situation-wise. AWS EventBridg. Everyone probably from you used some kind of queue like RabbitQ, ZeroMQ, or any other queues that are available currently. It's still form of queue. I added the routed part because it comes with the routing out of the box, which allows you to route the events to your specific consumers of the events. Um, Obviously, it lets you receive, filter, transfer, route, and deliver events as all of the queues allow in most cases. There's nothing magical here, actually. The magic starts below, so serverless. So we don't have to care about any servers. We just turn it on, configure the routes, and that's it. We don't have to care about anything. Even you can configure the dead letter queue, which basically is the queue that every event that was not fully processed or was not processed or where there were issues processing can land there. So the serverless part is very nice because you don't have to manage any infrastructure on your side. Obviously, the configuration can be still managed by Terraform or other providers, but you don't have to manage it per se. You don't have to update the service at all. Then, important and really nice thing is schema discovery. So basically, you can start sending events based on the type they will be aggregated, and you can even see that how the schema was changing as your application was being developed in time. If you turn that feature on, and it's free, so there are benefits of that. Last but not least is the integration. Basically, what's also important to know is that AWS itself is using EventBridge for many services that you can already react out of the box. So everything that is happening in AWS for your other things can be monitored using event bridges, and that part is fully free. There are a few things that you need to opt in or opt out if you need to, but it also can be easily integrated with Salesforce, PagerDuty, and I think 130 more services. So basically, PagerDuty will send, instead of SMS to a user, they will send event bridge event to your pipeline, and then you can play with that event as you need to. So it's very nice if you want to have some automated response to whatever is happening in your system. So basically, your VM is down. PagerDuty, instead of waking up a DevOps guy who will bring it up to life, will send that information to a Lambda that may recover it. And if it will not recover, PagerDuty can send next information in 2 or 3 minutes if that didn't help. That's actually the use case I used in one of the previous companies with PagerDuty, so I know it works really nice. And DevOps that can sleep more at night are more happy DevOps, so it's beneficial for everyone. And the last really nice thing is that it's very cheap. One event is up to 64 kilobytes, which is a lot, and 1 million event is $1. So it's really cheap, and I never seen cheaper service when it comes to queues or anything similar than AWS EventBridge. If someone sees that, please let me know, because running the VM, even the cheapest VMs, is more expensive than $1 currently. So that's really nice price for everything that you get here. Moving forward, the library we are using to develop our APIs, we created that internally in the beginning, then we open source it on GitHub. We have small amounts of users, but what is used for is for REST API, even API, Lambda API, so everything that we are using on a daily basis. And it simplifies and creates you interfaces between those three that are unified. It's really lightweight, which is quite important in Lambda because you have this limit of 50 megabytes by default, and then you need to extend it in other ways. But either way, it's really lightweight. It's fully type checked with MyPy and fully typed, obviously, in the code, and linted with Black, ISort, Flake 8, and PyLint. It comes with JWT support out of the box and has built-in local server, which is a really nice thing if you are developing the API for AWS, because there's no other service that has that in outside of the box to run the lambdas without any additional dockers or processes or additional servers. And it's being run on production for over 1 year, and at least 3 companies I'm aware of. So people are happy with it. That's all I can say for now, based on who's downloading those up and feedback we got, and I got this personally because I'm the main maintainer of that uh, from different sources. So show you how the REST example looks like. As if you remember Flask, and I probably think everyone used Flask at some point or similar. It's quite simple. You add a road, select the method that you are interested in, and create the flow that you want to do with the REST data related. Those are obviously the most basic examples, but let's let you know how simple is it to create a new API, and that would be working API with 3 more lines of code that you need to add later on. And yeah, so now we go to the most important thing. We have the event emitters examples. So we have defined event types. We are specifically defining them as a type that can be then used later. So that's consistent every time we use, because there can be, in some cases, different sources of the, for example, user registered action. So we have 2 ways of handling that also. We have the event emitter decorator that we can add anywhere and just register event that needs to be sent. And this decorator will send the event after the whole processing of the function will be finished when needed, and still return the appropriate result whenever we do it. And also we have, because we are working with the REST APIs, we also created the way of doing that within the event aware resource that will send the event after everything was done successfully. So that's also important, that we usually care about events that are done successfully, but you can also obviously extend that logic to handle the unsuccessful ways also. And event broker, as you could probably expect, that's quite very simple. There's a lot of logic happening there about how it should be handled. Basically, because you can react to an event in multiple ways, because we are reacting to an event, you are not expecting any response. You can pass a list of handlers that are just Python functions that accept event and return nothing to your event handler. You can have multiple of those, and very common example is as we start with the booking with the bot of a book order API. We can just send new order, and then we can have 3 handlers here send information to the client about the order itself, send information to the staff members that there's a new order, and send an SMS to someone else if needed. So we can have multiple handlers defined on the based on the process of the business process we want to handle. And yeah, as you can see, everything is fully typed, even in our example. So it's very easy to start working with that library, and I would eager you to try it out for REST API, for Event API or Direct API. The Direct API is very similar to Event API, and well, the rest is, as everyone knows, very, very simple, because it's based on Flask approach to make things as clean as and readable as possible. And We are just on the schedule of 30 minutes behind us, and we can go to the questions and answers. Sure. Okay. Sorry. What we did actually was to have the version of the event specifically as a part of the data payload in some cases, but because we are owning the whole, well, all of our APIs are owned by us, and we have also common library where we define those types that can be easily then switched between those. And we also have that typed to entities. We basically, when we were releasing new version of the API, we are also releasing at the same time the new version of our common library. And in the future, we'll split that common library that it will be released with as a library for each of our APIs. So the versioning will not be needed then. We had to version at some point that, but for a very short time, and then we move out from that idea. So basically, all of the services are now being deployed together. So whenever we change a version of the events, unless it's a well, we didn't have any complete rechange of the event, but usually what we did was to deploy everything that is compatible with each other. But yeah, versioning is an issue, especially if we are working in distributed teams and each team is supporting only one API, then versioning is becoming more important. There is a specific API like Swagger for event-driven architecture, uh, and it's helping with that versioning also. One of the points on our list for lambdalizator is to have that generation of the YAML for this event Swagger, let's say. I don't remember the name. On our list of things to do, so we can actually create that dynamically based on the events that we have. The routing, basically, that's the biggest difference. The routing is the biggest one. The schema recognition is the second. SQS does not support both of them. You can use SQS also for event-driven architecture. It's fine. And for example, we are using SQS as our data queue. So everything that goes to SQS to EventBridge and is not processed correctly will go to SQS, for example. Um, The pricing, I think, is even similar. So on the price wise, it's not that important. The EventBridge also has one more feature that I didn't mention because I didn't use it a lot. Is recording the flow of the events. So you can record like 1 hour of events that are happening in your system, and then use it for test purposes every time when you need it. And that's also especially for analyzing the events, observing the events is very important feature that SQS doesn't have. So that will really depend on the use case, but the routing is a really big advantage of EventBridge over SQS. Uh, that's what I said. It's about reacting to the events. So you can have 4 or 5 reactors that are reacting to the events, and even if one fails, usually it shouldn't be an issue because they should be decoupled from each other. Even if you have in the code that I show, you can have multiple in the event broker that I showed here. You can have a list of them. Even if all 3 fails, it's not still processed. It will be marked either to the letter Q at the end if all of them fail, but if at least one was successful, it will be processed to some degree. It's problematic actually. That's correct, but that really depends on the number of services that you have and the business processes. Well, with AWS, if you are doing it serverless, it will be very similar or the same even, because you are paying for Lambda invocation either way. And that Lambda invocation is the main cost still. So even if it's done directly, the cost will be the same, or even for event architecture can be lower. But currently, we are we were processing in my previous company around, I don't want to say too less, but around 6 or 7 million events per day. And the cost was $6 or $7. If we would use RabbitMQ instead of that, we would need to have a cluster of 3 nodes. We had that before, that's why I know that specific case, which was costing us around $250 per instance. So that would be $750 per month. So there's price benefit comparing to the, let's say, VM architecture, but comparing REST to event, that will be really depending on the on specific case, because usually all of the associated reactors to the specific event type will run. The run time can be very short in some cases, but it can multiply them. Um, we did that comparison, obviously. We didn't want to create something new. The Chalice, we had a lot of issues. That was actually, we started with Chalice. It was creating, well, the biggest reason was that we couldn't fully control the AWS permissions that we are attaching with the Chalice, with Terraform. And because of that permission that had to be done separately to the Chalice, we decided that it's not a good fit for us. Serverless frameworks, we were not happy that it's done in Node.js and doing a lot of things in the background that were not fully clear because there were no Node.js developers on our team at the time. And we're not exactly fond of that project. Yeah, but they were considered around 2.5 years ago. I don't have the freshest information about that, but at the end of the day, they only support the REST API out of the box and direct Lambda invocation. It was from their perspective that would be not enough. Yeah. Well, there's also basically there's library, I don't remember the name now currently, that allows you to run any common framework like Flask, Fast API, Async IO, Falcon or Django even, that converts basically any request coming to the Lambda to that framework of your choosing and of your choice. And we were thinking about using that at some point, but that actually appeared after we created lambdalizator, so it was a little bit too late for us. That option appeared later. But yeah, that would be also, if we would have that at the beginning of the project, we probably would use Fast API plus that wrapper that allows us to use that allows us to use that specific API for REST with AWS Lambda. How can you share the presentation, please? Yes, I will. Actually, I can send the link here. I will. I thought it was even on the last. No, that's not on the last slide. It will be at diba.it.pycon.tool.pdf. It's not there yet, but it will be after the presentation. There's make a science about it. Yeah, I will share that. Maybe in a window. Yeah, yeah. We'll be there by the end of the day, basically. Probably just after the presentation, I will upload it. Just remove the slides about me because that's not important for anyone, basically. Sure. PL, sorry, PDF was my mistake here. PDF, I did PL because PyCon is PL, so PDF at the end. So if anyone needs to make a picture, we can correct that one with PDF. I hope so. Well, you can have well, logs as the first thing. That's the easiest one, but you can also have custom logic that you want to implement above the event broker. We have, if you go, I don't, prepare these. I will share the code itself because it's simple and easy to understand. No, it's base. 1 second. Presenting, start presenting. And so this is the code directly from library. Okay. This window. So this is code directly from the library. So the library allows you to have pre-handle and post-handle defined. The pre-handle is being run unsafe if needed. Well, basically out of the box, and the post-handle is being run unsafe always because we already need to return the information if something happened, and that's generic version of that handler, which is based then for Lambda handler and the event handler. Obviously, they work in different way, but the base is the same, and in future REST API will also use the same base handler. So it's more common among them. Currently, it's being used the call and the structure on your running the API itself, and it will be deprecated. But you have the pre-handle and post-handle where you can add anything you need to, and it will happen basically always. with lambdalizator at least. But in generic reactors, you need to implement the code yourself. No, it's the second one, get and fire basically. You can record a set of events, or you can enable recording of set of events or on the time period that you want to be able to rerun basically for testing purposes. And you also have the letter queue where events can't land basically, so if they are not correctly processed. But you cannot basically go as you would go with RNQL or well, RNQ is the best example, and just download the events if they are being sent there. Obviously, you can route every event to SQS directly and then store them in SQS if needed. But yeah. As I mentioned, mostly about the control of the access for the lambdalizator, and it's much smaller project currently, so really much lightweight. But as I mentioned, I did the comparison 2.5 years ago when we decided to create the library. So I would need to run the chalice now again to see what they developed during this last 2.5 years. So I cannot fully honestly answer that question on the current state of things. My last information about chalice is from 2.5 years ago. I did not have any experience with NATS. I had some experience with Kafka in different project about network traffic analysis. In the past, but it was 7 years ago, so not in the AWS even, it was on-premise solution. And it's completely different approach basically. But yeah, the Kafka is really good for event-driven development either way, and many people use it for that specific case, especially for the observability. We did, and other people usually merge that with rules, for example, as a rule engine, and that the rules or other rule engine, because there are more, detects the anomalies out of the box or based on the rules that you have. Thank you. That's my plan too. Thank you, and have a nice end of the conference.